Hello, I'm Mr. Singleton, one of the Associate Directors for Science for Outward Academy. This lesson is part of what we call P3 from the specification, and it's all about changes of state and the particle model. So we're going to look at this from the specification, which is density. You need to know the equations for density. You need to know the units and the letters which are associated with that equation, and then we need to talk about diagrams between solids, liquids and gases, which is something that you might have done either in primary school or definitely in year 7 or year 8. As our pre-starter, I want to have a look at this cup here with some vegetable oil, some water, some dish soap, corn syrup and honey, and what I want you to look at is which layer in that cup do you think the particles are packed the tightest in? And then I want you to try and explain your answer. So why have you gone for that one? I'll give you 1 minute. Off you go. Okay, so what I'm hoping you've gone for is the honey, and that's because it's the most dense. And we use this word density quite a lot, but we don't necessarily always understand exactly what it means. So the particles which are most spaced out is probably in the vegetable oil, and the ones which are closest together is probably in the honey. So your title for today is Changes of State and the Particle Model, so that needs to be underlined with today's date. If you are doing this lesson at home, please make sure you've got any distractions away from you, and you'll need a pencil and paper. If you're doing this lesson in school, then you should be okay with your book or some revision cards. Okay, our challenge today is to describe what is meant by density and to be able to calculate density of different materials. So that's just looking at that equation that we were looking at before. And then our aspire is to explain why different states of matter have different densities. So I want you to have a think about these different situations. We've got some foam here, which has a mass of 0.03, diamond, which has a mass of 3.5, and iron, which has a mass of 7.8 grams. And they're all using the same units, they're all in grams. So which material has the greatest mass, which shouldn't be too difficult, and then explain which material you think has the heaviest atoms. And we're thinking about the heaviest atoms here, so you can think a bit to your chemistry, and which are packed most tightly. I'll give you 1 minute. Okay, so hopefully what you've done is you've gone for iron, which has the greatest mass. And notice I'm using the word mass here and not weight. And there's a reason for that, which you should be aware of, that weight is a force depending on gravity. Mass is the amount of matter there is in that substance. So iron has the greatest mass, and iron also has the heaviest atoms, which are packed closely together. We will look at what density is. So density is the mass per unit volume of a substance. So how much mass there is compared to its volume. And it kind of measures how compact that substance is, how close those atoms are, but also the mass of those atoms as well. And the unit for density is kilograms per meters cubed. AQA will want it generally in that unit, unless underneath in the answer block it says something else like grams per centimeters cubed, but it's very, very unlikely. So always trying to get it into kilograms per meters cubed. Now this always gives you a bit of a clue on how to work out the equation if you ever forget it, and it is one that you're supposed to remember. But if you get that unit there, kilograms per meters cubed, then you can find out the equation. Because I'm going to just go into this very, very quickly, but kilograms, well, that is a unit for mass. So you do the mass, and then that little slash line is like a divide sign. So it's mass divided by meters cubed, and meters cubed is the unit for a volume. So we already know now that the density is going to be the mass divided by the volume. If density of gold is 19,320 kilograms per meters cubed, well, what does that mean? That means that if we had 1 cubic meter of gold, then that would measure 19,320 kilograms. Very, very heavy, and very, very expensive if you had that. About 520 million pounds worth. So lucky you if you have got something like that. So like we said, if you look at that density and it's in kilograms per meters cubed, then it's just the mass divided by the volume. It's given this funny letter called rho. It looks a little bit like a P, but you have to be careful that you don't draw it as a P. It's like a italic P nearly. So it's density equals mass divided by volume, and you have to be able to recall it. You'll have to be able to rearrange it as well. So you're going to do this really nice and easy, and just try to do this for every equation that you do. I mark for AQA, I mark for AQA physics actually as well. So if you follow this step or these steps, then you're going to get the full marks, or at least the maximum amount of marks for the answer you've put. If you just put the answer and for some reason the answer's wrong, then you're not going to get any marks. But if you follow this way, you might pick up some marks, even if you put the number down wrong or something. So the first thing, if you are asked to find out the density of this substance, you write the equation. So put density equals mass divided by volume. You've got to do that. You're trying to show the examiners that you know as much as you can. We can't assume that you know everything. We can only mark what's on the paper. So put your equation down. That shows me, your marker, that you know the equation, and you generally get a mark for that. Then you are going to substitute the numbers in, and that's going to give you another mark. So you go to the mass of the foam, which is 0.03, and then you divide it by the volume, which is 1, which is nice and easy in this case. And then use your calculator. Please do use your calculator. It's not a maths exam where you're not allowed to use it. Use your calculator in the exam for your science. And then you write density equals, and you put that into your calculator. And again, some of you will have, I think it's a Casio calculator is I think the one that maths usually like to give you, and it'll give you it in a fraction form. You need to press that SD button at the top, and that will turn it into a decimal. So then you put the answer, density equals 0.03 grams per centimeter cubed, and remember the units, and that would be a 4-mark question, and that's how you get the 4 marks. So first things, write the equation. Next, substitute the numbers in. Next, write your answer. Last bit, put in the units. And you can see the units because you can see it's measured in grams, and then you put your dash, and then your centimeters cubed. Okay, so that's a model answer. That's how you get 4 marks in the exam. I want you to try and have a go at the other 2 questions for me. So I want you to do diamond and I want you to do iron. Off you go. Okay, for diamond, you should have got 3.5 grams per centimetre cubed. And then for iron, you should have got 7.8 grams per centimetre cubed. I put this slide in because it's one of the things that even my year 13 biologists get wrong. How many centimetre cubed are there in a metre cubed? And what a lot of people say was, right, I know there's 100 centimetres in a metre, so therefore there must be 100 centimetres cubed in a metre cubed. And that's where people go wrong. Because remember, when you are doing volume, you would have to times the base times the width times the height. So let's just have a look at this at the bottom here, this cube. If it's a metre by a metre by a metre, then that would be a metre cubed. If you wanted that in centimetre cubed, then you would do 100 centimetres times by 100 centimetres times by 100 centimetres. So actually 1 metre cubed is 1 million centimetres cubed. So don't let that trick you in any of the exams. Make sure you work it out properly and carry it out the way I've shown you. Otherwise you'll go wrong. So I want you to have a go at these now. These are a little bit more difficult than just dividing it by 1, but it's the same idea. So I want you to calculate the density of water, and again, write out the equation, then put in the numbers, then put it into your calculator, and then use your write the units for it. So a 200 centimetre cube bottle of water has a mass of 200 grams. Calculate the density of water. And then number 2, a wooden post has a volume of 0.025 meters cubed and a mass of 10 kilograms. Calculate its density. I'll give you 3 minutes. Off you go. Okay, you got 1 more minute. Okay, so the water calculation, what you should have done is written out the equation, which is density equals mass divided by volume, then plugged in the numbers, so 200 divided by 200, and that gives you 1 gram per centimetre cubed. So that means 1 gram of water will take up about 1 centimetre cubed of space, of volume. Next one, the wooden post. Again, write out the equation, density equals mass divided by volume, then you get a mark, then plug in the numbers, that's 2 marks. So then you've done 10, which is the mass divided by the volume, which is 0.025, and that gives you 400 kilograms per meters cubed, and that would give you 4 marks for that question. So we're going to look at some of these questions which have equations in that you're going to need to rearrange, and we're just going to get into good practice with doing these because this is usually what you get in your exam, not just a straight plug in the numbers. So in this case, we now have the density. It says if the density of a block is 15 kilograms per centimetre cubed and the mass of the block is 30 kilograms, what is the volume? So to do this question, the first thing you do to get your first mark is plug in do your equation. So it's rho, or density, equals mass divided by the volume. Now you put in your numbers. Well, I know the density, that's 15 because that's right here. Okay, and I know my mass is 30 because that is right here as well. But I don't know the volume. Okay, this is the harder one to do. So what I want to do is get rid of this v down here, this divided by v. So to get rid of that v, I do the inverse, which is times it. But whatever I do to that side of the equation, I have to do to this side. Now I've got 15v equals 30. Now I need to get rid of this 15 over here. So same thing, if I divide this by 15, I do the inverse because that's 15 times by the volume. Then I have to do that here as well. So now I've got V equals 30 divided by 15. Put that into your calculator and you will get that V equals 2. And that will give you your third mark. For the last mark, you need to put in your units, which is centimetres cubed. Okay, that'll be a 4-mark question, and that's how you rearrange the equation and show the examiner you know what you're doing. The last part of this lesson is to explain why different states of matter have different densities. So this is just looking at when you were in like primary school maybe, or definitely year 7 and 8, when you've drawn the particles in a solid, liquid and gas. And please remember that's all this is talking about. If you get a 6-mark question about solid states of matter, you just need to write about solids, liquids and gases. Okay, lots of students come out saying, I don't know what states of matter meant. It just means a solid, liquid or gas. So if you think about when you drew those particles for a solid, all the particles are really tightly together. They're all touching and they're all packed very closely together, which means then that they have a really high density because there's lots of particles in a very small volume. In a liquid, the particles are slightly further apart, which means then their density is a little bit lower than a solid, but much higher than a gas. In a gas, remember the particles are everywhere. There's lots of space in between them, which means there's not very much mass in that volume of gas. So that's how the density changes, and that's why the density changes. What I want you to do is give me 3 examples of a solid, a liquid and a gas for question 1. Then explain why solids have higher densities than gases. which I've tried to talk about already, and then which states of matter have the strongest and which ones have the weakest forces. I'll give you help with question 1. An example of a solid is ice, and please remember that ice is a solid. It's one of those misconceptions that students have. Ice is a solid, and then when it melts, it becomes a liquid. So any liquid could become a solid. You think like chocolate can be a solid. It melts, it turns into a liquid. If you heat it up enough, I think it burns actually, but it doesn't turn into a gas. But water is one of them ones that can be all. Water can end up being a solid, which its solid form is called ice, and it can turn into steam, which is its gaseous state. So just a reminder that water goes into all of those, but it's called something different. Same with lots of different things. You can have molten rock, lava, and then it can solidify into a solid. So it can be a liquid and a solid. Okay, so I've probably given you loads of answers there. I'll give you 3 minutes, answer those 3 questions, 3 examples of each. So I want 3 examples of solids, 3 examples of liquids, 3 examples of gases. Why does a solid have a higher density than a gas? And then which states of matter have 1, the strongest force, and 2, the weakest forces? Off you go. Okay, so last part of the lesson, just if you want to make a revision card on this. So density is the mass per unit volume of a substance. So how much mass there is compared to its actual volume that it's taking up. It kind of measures the compactness of a substance, and density is measured in kilograms per cubic meter. And the equation you need to remember is density equals mass divided by volume. And don't forget those bits of rearranging equations that I've put in there as well. Really well done, guys. Keep up the good work.